Where is the driver?
Yeah, even I am getting late. Sorry for the delay, guys.
What's wrong?
The bus is not starting. The battery must be down. Let's check the engine.
But
What's wrong? The battery must be down. But I don't have anything to check the battery.
don't worry, guys. I have battery level indicator.
Good morning, everyone. My name is Mayank Parab.
Myself, Pritesh Patil. And I'm Shivam Navle.
Today, we are performing the project of 4-level car battery voltage indicator using LM324 comparator under the guidance of Professor Najib Ghatte and Professors Sneha Weakey ma'am. The main aim of this project is to monitor the voltage level of a car battery and indicate its condition using LEDs. This project helped us understand comparator circuits, voltage division, and practical implementation of analog electronics. In vehicles, battery condition is very important because low battery voltage can prevent the car from starting properly. Many times battery failure happens without warning. So to solve this issue, we designed a simple voltage indicator system which continuously monitors the battery voltage and displays the condition using multiple LEDs. The main objectives of this project were to design a voltage monitoring system, understand comparator operation, and implement LED based level indication. This type of circuit can be used in car batteries, UPS systems, power supplies, and basic voltage monitoring applications where quick visual indication is required. In this project, we used the LM324 quad op amp IC, LEDs, resistors, a potentiometer, DC power supply. The potentiometer is used to vary the input voltage during testing, while the resistor network creates reference voltages for comparison inside the LM324 comparators. Working principle. The working of this circuit is simple. First, the potentiometer generates a variable voltage, then the voltage divider scales the voltage to suitable levels. The comparator compares the input voltage with predefined reference voltages. As the voltage increases, LEDs glow one by one, indicating high battery voltage levels.
A comparator compares two voltages, the input voltage and reference voltage. If the input voltage becomes greater than the reference voltage, the output changes states and the LED turns on. This process is repeated across all comparator stages to create multiple voltage level indication. In next slide, we see the hardware and simulation results. This slide shows both the practical breadboard implementation and the simulation results. During testing, we observed that rotating the potentiometer changed the voltage level and LEDs glowed sequentially. The hardware and simulation outputs matched correctly, proving that the circuits worked successfully. In next slide, we see the advantages, limitations and future scopes of this project. The main advantages of the project are low cost, simple design and easy implementation. However, it provides only basic voltage indication and not highly accurate battery management. In the future, this project can be improved adding LCD displays, buzzer alerts or microcontroller based monitoring system. So, in conclusion, we successfully designed and implemented a 4-level car battery voltage indicator using the LM324 comparator IC. Through this project, we gain practical knowledge about comparators, voltage dividers, and analog electronics. Thank you.
Now we will look at the simulation of this project.
So this is the simulation of our project. We have used the scale down concept, the reference voltage using potential voltage divider of 1.5K and 1K resistor. We are dividing by a factor the input voltage by a factor of 2.6. So if we give 12 volt input, the reference voltage of the negative terminal of op amp becomes 4.8 volts. And for the reference of the positive non-inverting terminal of the op-amp, we have used 5 volts inner diode. So the all the voltage above 5, when the voltage reaches above 5 volt, this inner diode lets pass the maintains the voltage at 5 volt. These are our 4 LEDs for 4 different level of indication. of 10 volt, 11 volt, 12 volt, and 13 volts. So when we make the input 12 volts, as we can see, three LEDs go on for the circuit. Uh, as we use potential dividers for the reference, the non-inverting voltage of the first op amp is 5.1, the second is 3.7, the third is 5.2, and fourth is 1.5 volts. If we want to measure voltage of different levels, uh, we can just change the registers, and this voltage level indicator can measure voltages across long range. These 500 ohm resistors, we have used them as current limiting resistors. So this is our circuit.